Just break my heart. What do you feel? Chasing the feelings from ghosts in the sky. I hope they don't mind. I need you near. Something to hold someone I can call mine. Please don't break my heart. Just break my
Hello, hello. Hi, hello everybody. My name is Stacey Bruno, and I'd like to welcome you back to my channel. And today we begin a new journey. We are going to learn Rust together. Rust is a programming language. It's a general purpose programming language, it emphasizes performance, type safety. It's a very restrictive, it's not truly restrictive, but you know, very memory safe. Memory safety is actually the first, memory safety is actually the biggest selling point of Rust. Uh-huh. Oh, okay, so why don't we just begin? What am I even? speaking for us. Okay, so Rust is a general purpose programming language emphasizing performance, type safety, and concurrence. It enforces memory safety, meaning that all references point to valid memory. It does so without a conventional garbage collector. Rust does not enforce a programming paradigm. It is influenced by the idea of functional programming, like Haskell, I suppose. Right? Haskell is a Haskell is a functional language. Mainly relies primary building blocks of memory, emphasizing immutability, avoiding side effects. Right. Made by the Rust team, first appeared in 2012. Oh, it started off as a personal project for a Mozilla employee. Mozilla Firefox. Mozilla Firefox, one original web browser out there. Because, you know, you know how it is. Everything else is just a Chromium wrapper. Brave is a Chromium wrapper. Edge is a Chromium wrapper. Chrome is a Chromium wrapper. Chrome is literally Chromium, right? So the best way I thought to go about with this is by using this language. Sorry, this no, by using this website. It's also a book. It's called Rust by Example, or there's also a book, if I'm not wrong, Rust by Practice. Learn Rust. So obviously this is the best resource to learn Rust from. Who made this? Okay, there is a couple of open source lovers of the language, you gotta have the dedication. Okay, why don't we just begin? Right? Give me 1 minute. I hope that's not too loud. Here. So Rust is a modern systems programming language focusing on safety, speed, and concurrency. It accomplishes these goals by being memory safe without using garbage collection. So Rust, by example, is a collection of runnable examples that illustrate various Rust concepts and standard libraries. To get even more out of the examples, don't forget to install Rust locally, which I do have Rust. Let me see. I had Rust installed locally. Did I not? Okay, I do. I have Rust, I have download. Everything's up and running. Rust, by example, is a collection of runnable examples that illustrate various Rust concepts and standard libraries. To get most of these examples, install Rust locally and check out the official documentation. Okay, this is a standard library. Okay, we'll get into that later. Also, check out the source code for this website. That's nice. Let's begin. Let's begin with a traditional Hello World program. Okay, that's fairly simple. This is the source code for a traditional Hello World program. Comments are written somewhat similar to C. This code is editable. Feel free to hack it. Huh. This is the main function, fn main. Statements here are executed when a compiled binary is called. Uh-huh. So print line is a macro function. It's a macro built-in that prints text to the console. A binary can be generated using the Rust compiler Rust C, like GCC, G++. I suppose that's what the C compiler is called. Rust C will produce a hello binary that can be executed. This is an exe. So you compile it using Rust C, and then you execute the exe, click run above to see the expected output. Next, add a new line with the second print line macro so that the output shows. Okay. Not that. I don't want Visual Studio. I want Visual Studio Code. This is the IDE that we will be using. Okay, so why don't we begin by writing the main function, F in main. I need to find a book. There's a really good book. Uh, where is it? Is this the book? No. Yeah. It's the Rust programming language, written by Steve Klubnik, Carol Nichols, wow, and Chris Crichton, with contributions from the Rust community. This version uses Rust 1.8, 1.82.0. What am I using? 1.85.1. I hope that does not lead to conflicts. hmm Okay. So Rust is a systems level with deals with load level details of memory management, data representation, and concurrency. This realm of programming is seen as arcane, accessible to the only few who devoted the necessary years learning to avoid its infamous pitfalls, and even those who practice it with caution. Sure. Let us break down these barriers by eliminating the old pitfalls and providing a friendly, polished set of tools that help you along the way. Programmers who need to dip down to lower level control, I assume they mean kernel level control, can do so with Rust. Okay, that's actually exactly what I need. Without taking on the customary risk of crashes or security holes, and without having to learn the fine points of fickle toolchain. Mhm. Programmers already working with low-level code can use Rust to raise their ambitions. Introducing parallelism in Rust is a relatively low-risk operation. The compiler will catch possible mistakes for you, and you can tackle exhaustive optimization with the confidence that you won't accidentally introduce crashes or vulnerabilities. Rust is not just limited to low-level systems programming, it's expressive and ergonomic enough to make CLI apps, web servers, and many other kinds of codes quite usable. Right. So the main reason that I wanted to look into Rust was one, obviously for low-level programming, and second was for blockchain, because I remember, if I am correct, Solana, the blockchain, is written in Rust, right? Yeah, see, Solana programs are primarily developed using the Rust programming language. So I wanted to check this out and understand how it works. So that is one of the main reasons that I'm looking into Rust. This book fully embraces the potential of Rust to empower its users. It's friendly and approachable text intended to help you level up, not just with the knowledge of Rust, but also reach confidence as a programmer in general. Okay, the Rust programming language helps write fast programming software. Yeah, we read that already. It's ideal for a team of developers, students. Hey, that's me. Companies, open source devs, people who value speed and stability. Me again. This book assumes you've written code in another programming language. Yep. But doesn't make assumptions about which one. We try to make the material broadly accessible to those from a wide variety of programming backgrounds. We don't spend a lot of time talking about what programming is or how to think about it. That's not a problem. We already know what that is. Hmm. How to use this book? This book assumes you're reading it in sequence from front to back. Later chapters build on concepts in earlier chapters, like any good book should. Earlier chapters might not delve into details about a particular topic, but will revisit it in a later chapter. So there's two types of chapters in this book: concept chapters and project chapters. Concept chapters we learn an aspect of Rust. Project chapters we build small programs together. A pragmatic approach to learning. That's exactly what I need. So chapter one explains how to install Rust. Obviously, I already have Rust. It's in its compiler. Okay, we will get into this as we approach them, right? Important part of learning Rust is learning how to read the error messages the compiler displays. This will guide you towards working code. The compiler is really good. It actually tells you what went wrong, went well. It actually gives you a CLI output. It knows where you went wrong, not just a typical debugger. Okay, let's get started. Install Rust on Linux, Mac OS, or Windows. So I'm using Windows. Write a program that prints Hello World. Use Cargo, Rust's package manager, and build system. Okay. Now the first step is to install Rust through Rust. Okay, I'm already done with that. I have Rust. Um, well, in case if you do want to install Rust, you could go, you could check out this website. I'll leave the link in the description. You could check out the website. It's really good. It's really one place where you could learn everything about Rust. Mhm, mhm. And for text editors, I obviously will be using Visual Studio Code. Okay, that might be a little problem. Um, okay, I'll say something. Okay, now that you've installed Rust, it's time to write your first Rust program. It's traditional when learning a new programming language to write a little program that prints hello world. So we'll just stay here. This book assumes basic familiarity with the command line. Okay, yes. Rust makes no specific demands about editing or tooling or where your code lives. So if you prefer to use an IDE instead of a command line, feel free to use your favorite IDE, Visual Studio Code. Actually, no. Well, create a project directory. I already have a project directory. Let me see if I can showcase that. I don't know how to showcase it safe in a safe manner. No, right here. This is my project directory that I will be using, stored in desktop. Okay. Uh, actually, I can just show you guys. And let's go. Okay. Over on that. We go into users. We go into admin, and we look for desktop, and there it is. Where is it? Where is it? Where is it? What? Right here, a directory called Rust. So I already have a directory pre-made. If you guys want to go ahead and make one, these are the steps. No, these are the steps for Windows. Anything else like PowerShell, Linux, or Mac OS would use these. Next, we make a source file and call it main.rs. Rust files always end with the .rs extension. So if you're using more than one word in your file name, the convention is always to use an underscore to separate them. Guys, naming convention very important. Uh, so we use hello world.rs rather than hello underscore world.rs rather than hello world.rs. Now open the main.rs file and enter the code in listed one one. So let us open the Rust directory and see what we have in there. Look at that, we already have uh, a directory for hello world. I can't, oh no. So these are two different methods of making a Rust directory. So one I did by hand and one I used the package manager called Cargo to do so. We're going to come across that eventually. So I don't know how to delete a file, so let me look at the command to delete a file. Del. Okay, what? It cannot. What? Why is it not getting deleted? Might as well open it in this folder. Okay, now we're starting fresh. Okay. So why don't we follow along with the book and its instructions? The first we make a directory. We make a directory for our project, and then we make another directory for the Hello World project. Okay, so we're in Rust. We make a directory for projects. Uh, Okay, we have a directory for project. Now we end the projects. And then we make a directory for hello world. And of course, we use underscore, good naming convention. And now we enter that directory. Okay, perfect. Now, as you can see, my command prompt is pointing towards the hello world directory, which is inside the projects directory, which is inside the Rust directory on my desktop. Okay, perfect. Okay, next we make a source file and call it main.rs. Main.rs. Okay, how do we make a source file? We create a source file. We create a file using the echo command. Isn't it Linux? No, that would be for plain text files. Hmm. Hmm. Okay, why don't we just do it over here? We just make a source file here inside Rust. Ooh, that is painful. That's painful. Okay, we have projects, we have hello world. We make a new file called, not a new folder, what, new, why don't we're gonna take the easy route out, and we are going to make VS Code point to Rust. Desktop, Rust, projects, hello world, select folder. Okay, perfect. Okay, now we make a new file called main.rs, main.rs, and as you can see, Rust has kicked in. If you guys can see right there, the logo. Now we have our main.rs, which is our main source file, Rust files policy and in a .rs extension. Yep, okay, good. Now we write our code. Mhm. Function main we so this is pretty similar to C, except we are not specifying the return type. We just call it function. I suppose the compiler takes care of that. Very modern. That's all I can say. And then we call the macro called print line, and we write our message hello world. And we use a semicolon. Is that called a semicolon? Oh my god. Yeah, we use a semicolon to end our line, and we end our block of code using that. Perfect. What's next? Save the file. Save the file and go back to your terminal window or Linux or macOS or Windows and enter the following commands to compile and run the file. So we save it and then we go back to our command line, interface, terminal, something. Okay, we are here. Now we want to check for our main.rs. We have main.rs. Now we've used the command rust c. Like let's say if it was C, we would use gcc to compile our source code. Uh, rust c main.rs. Good. And as you can see, it has been compiled and we have an executable ready. Now we want to run our executable. Let's see if I can just run it plain and clean. Okay, there we go. I don't know if you guys can see the output. Look, there we go. Here we compiled it. Whoa, where are my commands? Where are my commands? Yeah, right there. We use Rust C, the compiler, to compile our source code. And after compiling it, we got the executable. And here I ran the executable. And here's our output. Hello world. Pretty simple, pretty clean, very nice. Okay. Regardless of the operating system, the string hello world should print to the terminal like it did. Looks like that. Okay. If hello world did print, congratulations. You officially written a Rust program that makes you a Rust programmer. I am now a Rustacean. Let's go. Now let us review this Hello World program in detail. Here's the first piece of the puzzle. We declare the function itself. We call it main. No return type. I suppose the compiler takes care of that. These lines define a function named main. The main function is special. It's always the first code that runs in every executable Rust program. Here, the first line declares a function named main that has no parameters and returns nothing. Obviously, as you can see, it has no parameters, no arguments to pass, and it does not return anything as you not. I suppose you've not provided the return type. So I suppose you need to write fn to define a function. If there were parameters, they would go inside the parentheses. Pretty similar to C, pretty similar to C++. Very, very good, very clean. The function body is wrapped in these. Obviously, the Rust requires curly brackets around all function bodies. It's good style to place the curly bracket on the same line. Bro, that's just basic. You don't have to teach me how to write code. I know how to write code. The body of the main function holds the following code. Print line, hello world. This line does all the work in this little program. It prints text to the screen, and there are four important details to notice here. Four important details. First, print line calls a Rust macro. If it had called a function instead, it would be entered as print line without the exclamation mark. We'll discuss how Rust macros We'll discuss Rust macros in more detail in chapter 20. For now, all you need to know is using an exclamation mark means you're calling a macro instead of a normal function. So let's say if you were to define a function, you would call it without exclamation mark. Okay. And Rust macros do not always follow the same rules as functions. Second, you see the hello world string. We pass the string as an argument to the macro, and the string is printed to the screen, obviously. So you have print line, and the entire point of this macro is to print text onto the terminal, and we pass the argument as this string, and after compiling it, we obviously get our output, which is hello world in the terminal. Very it works as it's intended to. Third, we end the line as with a semicolon, obviously we all know that, which indicates the explosion is over and the next one is about to begin. Compiling and running are separate steps, obviously, like any technical language. You just created a new program, so let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by using the Rust C command and passing the name in the source, like we did. If you have a C or C++ program, yeah, see, this is what I was telling. If you were to C, they would be using something like GCC or Clang to compile it. After compiling it successfully, Rust outputs a binary executable. Yep. Now this is for Linux and Mac OS. Okay, you'll see the same three files that you've seen in the command. We have the executable, we have the source code, and we also have this file that I suppose holds your dependencies or whatever you need to run the actual code. Okay, the source code is with the .rs extension, the executable, and the .pbd file. You can keep the debug information. Okay. If you're familiar with a dynamic language, you might not be used to compiling and running the program as simple steps. Obviously, you use interpreters, you don't use a typical compiler. Rust is an ahead of time compiled language, meaning that you can compile a file and give the executable to someone else, and they don't even need to have Rust installed. Very cool. I haven't heard of that. If you give someone a Ruby, Python, or a JavaScript file, they need a Ruby, Python, or JavaScript implementation installed respectively. But in those languages, you need one command to compile and run your program. Everything is a trade-off in languages. Okay, as the project grows, you want to manage options and make it easy to share your code. Next, let us introduce the Cargo tool, which will help us write real-world Rust programs. The Cargo tool, what's that? Cargo is Rust's build, system, and package manager. Most Rustaceans, like me, Use this tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries that your code depends on, and building those libraries. And we call those libraries as dependencies because your code cannot run without those libraries. The simplest Rust programs don't need any dependencies. If we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As we build more complex programs, we'll be adding dependencies. Because the vast variety of projects use Cargo, the rest of this book assumes you're going to use Cargo too. Well, it doesn't hurt to learn how to do so. I have Cargo. Let me check my Cargo version. Okay, see, I have Stack 1.8.5.1. Okay, let's create a new project using Cargo. And we will see how it differs from our original Hello World program. So I'm back. I'll take care of that noise. Okay, let's see. Let's see how building a program with Cargo differs from using a traditional approach like that. Now we navigate back to our projects directory and we run the following. Let's use Cargo, shall we? So we navigate back to our projects directory. Uh, okay. Now we are pointing to our projects directory. Let me show you guys that. Now we are pointing to our projects directory. Now let us use Cargo to make a new project. Cargo new hello cargo. So we create a
What's on your
binary.
mind? Can I read
Okay,
it from your
let's
eyes?
check what is in there.
Can relate. Underneath the times
Folders
but
for
still.
Git.
What if we
It's normal.
stay?
What's that?
Pretend there's nothing
What is that? Never heard of that.
else.
So we have hello cargo. Over here we have the Git file. We have the source code, functions.
What if we
No, main functions, the
stay?
main. And we have a TOML. I have no idea what that is. Okay, so it describes the project. It has the name and the version, and I suppose it skips updating as we make changes to our project. And the addition, that's not true, it's 2025. And it also lists the
What's on
dependency.
your mind?
Very useful.
Can I read it from your eyes?
Mhm.
Can relate. Underneath the times
What's
but
next?
still.
You see the cargo has generated a Git file, a Git ignore file. Git files can be generated if you run it within an existing Git repository. Now, okay, this file is in Tom's obvious minimal language format. It has a section that indicates it's this configuration information for the project for the program.
What's on your mind? Can I read it from
Dependencies
your
lists
eyes?
any of the project's dependencies.
Can
Packages of
relate.
code are referred to as crates. We don't
What
need
if we
any other
stay?
crates for this project, but we will in chapter
Pretend there's
2.
nothing
Okay,
else.
now open the main.rs and take a look. The difference between our project and the Cargo project is that Cargo placed the code in a source directory and we have a normal configuration file in top of that directory. Makes it pretty easy if you're sharing it around with a team of devs, which is what they actually stated back then. Top level project directories is README files, license information, and configuration files, and anything else not related to your code. and we can convert it into a project that does use cargo. Move the project code into the source directory and create an appropriate TOML file. Okay. Now let's look at what's different when we build and run the Hello World program. From your Hello World directory, build your project using the following commands. Okay, let's start. Let's go down. So we do cargo. Wait, that's cool. That's really cool. I suppose you do this inside the source folder. Okay, so as you can see, it compiled my code for me. Why do you want to do that?
Got a monster inside of me. You better watch out if your enemies are road ahead of full prophecy to be the greatest beast the world has ever seen. I feed him every day like the bones clean. I feed him all the hate and he grows me. And he gets cause real big, pissed off quick. And if you cross him, you might drop
So
dead.
it has a dot law
Settling the score, never getting bored. Loves the blood
and
and
a
gold.
target.
Always wanting more freedom from the source. They don't really understand until they feel the force of art. And if you start shit, you be heartless.
Here it is annoying now. But cool, it's first, but now it's annoying. This command creates an executable file and target debug hello cargo or hello cargo.exe rather than putting it in a current directory because the default build is a debug build. Uh-huh. Uh-huh. Not a lot of it makes sense to me, but let's try to compile. Let's try to run it. Let's compile it already. Ooh, I hate that so much. I have to go all the way down. Okay, so we have a build directory, a dependency directory, an example directory. Let's check what's in there. The fingerprint directory. I don't want them fingerprinting my device. A build is empty. Dependency. It just has my executable. Examples is empty. Incremental is empty. And here's my executable. I reconnected that. Okay, let's try hello underscore card. I don't even have to type the .exe, but I reckon that's the same case if I use it in a conventional, traditional way. If all goes well, hello world prints to terminal. Running cargo build for the first time also causes cargo to create a new file at the top level, cargo.log. This file keeps track of the exact versions of dependencies in your project. If your project does not have dependencies, the file is a bit sparse. Cargo manages its contents for you. We built it using cargo build and ran it using hello cargo, but we can also use cargo run to compile the code. So cargo is, why do I keep doing that? Well, I use cargo run. It also compiles it and then runs it, but I already had it compiled. I think, I hope we don't have two of the same, uh, two exactly same executables now. That's not good for memory. Cargo figured that the files had not changed, so it did not rebuild, but just ran the binary. Wait, it did rebuild it. Look, it compiled it right here. If we modified your source code, Cargo would have rebuilt and we would have seen this output. But it did rebuild. Dana did not modify any code. Cargo also provides a command called cargo check. These commands check your code checks your code, and makes sure that it compiles, but does not produce an executable. Okay. Yeah, let's see, the code is perfect, but let's see if what if I change the source code? Let's see what if instead of calling a macro, I did this. I suppose it wouldn't work now. Yep, print line is not a function. Use exclamation to invoke the macro. So this is what I was talking about. It has a really, really amazing compiler. So this it told me what was wrong, and it told me what to do to fix it. Smart, huh? Let's change that again. And as you can see, the code is perfect. I checked my code to see if it compiles. It does, but it did not build an executable. Very useful, very good design. Why would you not want an executable? Cargo check is faster than cargo build because it skips those steps of producing an executable. If you're continuously checking your work while writing the code, cargo check can speed up the process. That's really sweet. That's amazing. Let's recap what we learned so far. We can create a project with cargo new. We can build it with cargo build. We can build and run it using cargo run. We can build it but not produce a binary just for checking errors using cargo check. And instead of saving the result of the build in the same directory as our code, Cargo stores it in target debug. It creates a separate directory for your executables. In addition, Cargo also uses commands that are the same no matter which operating system you're working. When you're ready to release it, you can use Cargo build release to compile it with optimizations. This command will create an executable in your target release. Okay, so it's taking care of my file conventions as well. So let's say if I was still debugging it, the executable would go over here. But if I'm ready to release it, it would create a brand new directory called release. This command will okay. The optimizations make your code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles. One for development, when you want to rebuild quickly and often, and another one for building the final program that you will give to a user that is not rebuilt repetitively and runs as fast as possible. If you're benchmarking your code's running time, make sure to run cargo build release and benchmark with the executable in target release. That's right. Cargo build release. 0.26 seconds. Except it was faster prior. What's that? Release profile optimize targets in 0.26 seconds. Huh. I mean, they did say that it would take longer to compile. With simple projects, Cargo does not provide a lot of utility or even just C, obviously, but it will work C as your programs become more intricate. Other programs grow to multiple files or need multiple dependencies, and Cargo can be used to coordinate the build. Hmm. This is Git stuff. I don't use Git. I'm just kidding. Just kidding. Summary. We installed the latest stable version of Rust using RustUp. We updated to a newest Rust version. We opened locally installed documentation. Rust has locally installed documentation. I didn't know that. Oh, RustUp doc. Hmm. It's great time to build a more substantial program to get used to reading and writing Rust code. So in chapter 2, we'll be building a guessing book, which if you would rather start by learning how problem. Okay, let's take the pragmatic approach. Let's jump right in by working on hands-on project together. This chapter introduces you to a few common Rust concepts and how we use it in a real program. We'll learn let, match, methods, associated function, Let's start with crates because you told me like a bunch of code is what a crate is, and I have no idea what a crate is yet. We implement a classic beginner program or guessing game. Here's how it works. The program will generate a random integer and then prompt the player to enter a guess. If the guess is correct, the program will indicate. If the guess is low, if the guess if the guess is correct, the program will print a congratulatory message, and if it's lower or higher, the program will then indicate what is wrong. Okay, so let's start. Let's use Cargo to build it. Uh, 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 okay, now we are in a projects folder. As you can see, the command prompt is pointing towards the projects folder. Now let us build a new project using Cargo. Cargo new testing game. Okay, so it's built. Now let's go inside our folder. And as you can see, it's right there. Now look at the generated EOML file. Very good, very cool. And by default, it's generating a hello world program. The first part of the guessing game will ask you if you user input, process it, and check it if the input is in its expected form. To start, we will allow the user player to input the guess and lose. Okay, so here's our code. This is a header file, I reckon, standard input output. Then we make our main function. Guess the game. Please input your guess. Let mutable guess. Okay, so you have to specify whether the variable will be mutable or not when you are declaring it. See, that's what I was talking about. Is it? Yeah. No, it's not. That's not it. This is what I was talking about when it's good design. You have to declare whether the variable is mutable when you are declaring. When you have to specify whether a variable will be mutable when you're declaring it. I hope that's right because otherwise this would be stupid. Mm, and then you're gonna ask the user to input a string, name it input output standard in, read the line, read the line. So read the variable, what is in your variable. Now expect fails to read line. In case it's empty, and in print line, you guessed yes. So this is the code that gets a user to guess something and prints it. Let's try writing that. No, that's not right. We want to open a file. We go to projects, interesting group, source, name, there we go. So we use standard input output main function. Uh, so we have a main function, and then we have to ask the users. We have to ask the user to give us his guess. Enter a number, and then we declare a guess. We guess a variable called guess, string type, I suppose. But I think in using int, you would be smarter. Input output standard in. This is where I suppose you're invoking something. Read line, read what is present at your guess variable. Save to line. I reckon if it's empty, then we print whatever the user guessed, or it is a type identifier. I don't know. So let us read what we have to say. The code contains a lot of information, so let's go over it line by line. First, we obtain user input, then we print the result as output. We need to bring the input-output library into scope. The input-output library comes from the standard library known as std. By default, Rust has a set of items defined in the standard library that brings into the scope of every program. This set is called a preload. You see everything you can see everything in it using the standard library documentation. Well, this is a very well documented language. I really like, but I reckon every language is then. So, mhm, mhm. So we understand what's happening to here so far. And now we make a variable to store user in. Now the program is getting interesting. There's a lot going on in this one little line. We use the let statement to create the variable, similar to Python, I think. And here's another example. Let apple is equal to 5. Like you can see, the compiler takes care of kind of um, what kind of variable it is whether it's an int or something like that. In Rust, variables are immutable by default. Okay, meaning once you give it a value, the value won't shift. We will discuss this concept in variables immutability. To make it mutable, we add mute before the variable. This starts a comment similar to C. Returning to the guessing game, we know that let mute will introduce a variable. The equal sign tells that we want to bind something to the variable, which is user input in string format, I guess. A function that returns a new instance of string. String is a string type provided by the general library. UTF-8 encoded bit of text. What is UTF-8? UTF transformation format 8. It is a coding system that uses 1 to 4 bytes to represent each character. It's backward compatible with ASCII as well. Uh-huh. I don't see any numbers in there, but I suppose this is not proper. Way above my pay grade, man. Is it really? No, it's not. The double colon syntax in the new line indicates that new is an associated function of the string type. An associated function is a function that's implemented on a type. This new function creates a new empty string. So what is string though? String is a string type provided by the standard library. And new is a function that is associated with the string type. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. So declaring this is not enough. You need to also return a new function of a string type. Huh. Instead, for this has created a line. This has created a mutable variable that is currently bound to a new empty instance of a string. So how would we input it? We use input output standard in. The Yes, so the standard input output library. You see that this is so here we are declaring, no, here we are invoking this input output library, and here we take input output library and we use standard in to take input. Very smart, very good, good design, good job. on the first line of the program. So we call the standard in function from the IO module. So the standard in function from the input output module. So this is a library, and then we call the function inside the input output module to handle user input. If we haven't, if we have not called this, so what they are saying is I can still do this, right? This should work just the same. And returns an instance of the standard in from the standard input output module. Huh. Now the next line, dot read line new guess, calls the read line method on standard input to handle getting input from the user. So we call the standard in function, and then we use the read line to get input from the user, and we pass it on to the address of the guess variable. That makes sense. This is a reference. Obviously, we specify reference. And then, what is the expected? They have not explained the expected. Okay, handle potential failure. Yeah. Mhm. As you can see, we have not ended the line over here, so this is basically the same thing. For results, variants are either OK or error. The OK indicates that the operation is successful. Error means the operation failed, and that could be because of multiple reasons. Maybe you have not declared your variable. Maybe you are out of memory. There could be multiple reasons. Result may be an error variant which should be handled. So they won't even let you run the code unless you have an expected. Um, and then we obviously will print the guess. We will obviously print the guess that we got from the user. Print off these curly brackets as little crab pencils. Hey, now we've come to the good. Look at Ferris the crab on the screen. He's right there at the bottom right corner. Look at his pincers. Think of those curly brackets as his pincers. Huh. When printing the value of a variable, the variable name can coincide the curly brackets, and when printing the result, evaluating an expression, we place empty curly brackets in the format string and follow the format string with a comma separated list of expressions, very similar to what we do in C and C++, very self-explanatory. As you can see, we want to print x as x and y as y plus 2. This would print x is 5 and y is 12. Yep. Mhm. So we're calling libraries as great now. Traits now. So we're calling in multiple traits for different functions. I would have written all this code myself, but if it ain't broke, don't fix it. Okay, let's try to run this first. What? Oh, I didn't save this. with the game. And remember, I will at 72. I guess 72, so that works just fine. Hmm. I'm gonna take care of the next part in a later video because I'm reaching the 1 hour time and I don't want this to be way too long and I don't want this to be too long and too boring. So that is where I'm gonna end for now. I reckon I'll be coming back some other time of the day. Until then, goodbye, sayonara. Have a great day, everybody, and stay tuned for more.